Hi, welcome. We're going to go over this question today, move zeros. We're going to uh, use the umpire process to solve this problem. So the problem is this: given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So let's first understand this problem. So what we have as an input is an array nums of integers. And then we have an output, and the output is nums where zeros are moved to the end. And non-zero elements maintain order. Okay, so let's get an example out of this and to understand what's going on. So we have example here, example 1, where nums is 0, 1, 0, 3, 12, that array. And then what we do is that we just take the first element of 0 and put it in the back, and we get 1, 0, 3, 12, 0. And then we take the second element of 0 and put it in the back, and we get 1, 3, 12, 0, 0. So we have an output of 1, 3, 12, 0, 0. And in example 2, if we have nums equals 0, then we just output 0 because it's already the front of the array is the same as the back of the array, so it's just 0. So now that we have an understanding of the examples of this problem, now we can go on and check out the match. So what's a match? So what are similar problems? I would say anything about list manipulation, and we need a loop and selection. So those are elements of this problem that are similar to other problems. And then we have a plan for this problem. So what we want to first do is we want to consider inputs, which is a list of nums. And then we want to set initialize count equal to 0. And then we want to um, uh, move elements of nums that are not equal to 0 up to the front. And then we want to append to the end the elements that are 0, or I should say set the rest of them. Okay, now that we have a plan, we can go about implementing this plan. So let's set count equals 0. The count is going to be the resetting of the nums to the given numbers that we want it to be. So for I in range length nums, we want an if conditional, or an if statement. So the conditional is if nums I doesn't equal to 0, then we set nums count. So the beginning of the array we wanted to set we just want to inch everything up, and then we increment count. And then, so that just increments everything up to say 1, 3, 12 turns into 1, 3, 12. And the rest of the array is just whatever the rest of the array is, but then we need to set the rest of the array. So for while length, while count is less than length of nums, then we want to nums count equals 0, and count plus or minus equals 1, and we want to return nums. So we got the solution accepted. The solution is accepted, so let's check out the review of this problem. So the review is here. We're going to go through this function. So this function, we're going to print this function with zeros, and then so we said count equals 0, and then for I in the range length equals length nums, we have the first statement where nums I doesn't equal 0, and that's actually the case. So we want to set the first element to that exactly. So we set that in count and add count. The second num is 0, so we skip to the next I, and then the second I is 2. So we're going to set the nums count, which is the index 1 to 2. And then we go to the next index. We go to 3, and then we check that 3 is 0, so we skip. And then we go to 4, and we see that 4 is 5, and so we set the index 2 to 5. And then we increment count, and then we go to, and then we do that for the element 6. And then we get out of the for loop, and then, well, count is less than the length of num, so the rest of the array that is going to be set to 0, then we set that to 0, and we return, then we are done return nums, and the array is 1, 2, 5, 6, 0, 0. So now that we have a review of this problem, now let's go and evaluate this problem. So evaluation, we have ON time complexity. Since we go through a for loop or one time through the length of nums, and and that's the max number of iterations, and then we have O1 space complexity because we use nums, we don't extend to another output array, so we don't use extra space to do this, so we have an order O1 space complexity. So that about wraps up the analysis of this problem with zeros. So thanks for listening.